All right, you guys, we're going to look at the DeltaMath assignment 2.A, evaluating function notation for compositions, so compositions of functions. So we're going to go ahead, and I have just some scrap paper that I'll be writing on over here. You might need some as well. So let's start off with the first section. So it says, given the definitions of f of x and g of x below, find the value of g of f of 2. So I'm going to find g of f of 2. And I'm going to start with the inside, so I'm going to start with f of 2, which would equal 3 times 2 squared minus 3 times 2 minus 3. So let's see, 2 squared is 4, so we got 3 times 4 minus 6 minus 3. 12 minus 6 minus 3 would give me, 12 minus 6 is 6, 6 minus 3 is 3. So I'm going to go ahead and I'm going to replace my f of 2 with a 3. So really what I'm going to be finding now is g of 3. So then for g of 3, I get, well, that one's pretty easy. 3 plus 1, we get 4. And they do the same setup that I do as far as their explanation. So. All right, let's try one more of these. So in this problem, they want us to find g of f of 1. So I'm going to start with the inside first, f of 1. So I'll have 3 times 1 squared minus 7 times 1 plus 6. 1 squared is 1, 3 times 1 is just 3, minus 7 plus 6. So I'll get negative 7 and 6 is negative 1, so 3 minus 1 is 2. So I'm going to go ahead and replace that with a 2. So really what it's asking me to find now is g of 2. So using the g function now, 4 times 2 minus 5, 8 minus 5, we get 3. Awesome. All right, let's go ahead and do some more composition, but this time we're going to have x's, so you're not going to necessarily put numbers into your functions. You're going to, at the end, have an expression or a polynomial. It says make sure to express your polynomial in standard form, which really just means that we have to make sure our degrees are in the correct order. So like f of x is in standard form already because I have an x squared first and then an x to the 1 secretly second and then no x's at the end. So it should go in decreasing order for your degrees. All right, this one wants me to find f of g of x. So that means I'm finding f of g of x. Oops. And so everywhere there's an input in here, right, I'm going to do something squared minus 2 times something minus 13. And that something I'm going to put in here is whatever g of x is equal to, so negative x minus 3. Ooh, we'll have to be careful here. There's a lot of negatives going on. First and foremost, one of the biggest mistakes I see is that students automatically want to start distributing exponents. Anytime that you have addition or subtraction inside of an expression, you cannot distribute your exponent. You actually have to multiply it out. It makes your life harder, but recognizing it is the first step. So what we're actually going to be finding here is we're going to do negative x minus 3 times negative x minus 3. Negative 2x minus, negative x minus 3, and then minus 13. All right, so we're going to actually FOIL. So negative x times negative x will give me a positive x squared. We're going to be very careful with our negatives here. We've got a lot of them going on. Negative x times negative 3 gives me a positive 3x. Negative 3 times negative x gives me another positive 3x. Negative 3 times negative 3 gives me a positive 9. And then if I go ahead and distribute this negative 2, negative 2 times negative x gives me a positive 2x. Negative 2 times negative 3 gives me a positive 6. And then I just have that minus 13 tacked on to the end. Now I'm going to go ahead and I'm going to combine all my like terms. So I got some regular x's going on, and I have some constants going on, and then I have just an x squared hanging out. So x squared is just going to hang out, and then I got 3x plus 2x, which will give me 8x total. 9 plus 6 is 15, minus 13 would give me plus 2. Let's go ahead and type my answer in there. Voila. And they'll work it out exactly the same way that I do. All right. Let's try one more of those just because they're a little bit tricky, and also we got to be careful with our notation. All right, so for this one, it wants me to find fog of x, which really, hopefully we recognize it just means f of g of x. It's just another way of writing it. All right, so if I'm doing f of g of x, what I'm doing is I'm taking my entire g of x function, and everywhere there's an input, I'm going to put that in for f of x, right? So I have stuff plus 10, and then the stuff I'm putting in is g of x. So I'm going to put in my x squared plus 2x minus 7. And then since I'm just adding 10 at the end, I don't technically need parentheses at all. So I just have x squared plus 2x minus 7 plus 10. And my only like terms that I can combine are my negative 7 and my positive 10. So I get x squared plus 2x plus 3. There we go. Awesome. Let's go back and we'll try our last one. So composition of functions, it says 3. Okay, so this one's going to be multiple choice, but basically we just have to figure out if you composed 3 functions, what would happen. And it works the same way as if you composed 2. So t of c of g of x is what we're finding. So t of c of g of x. 1, 2, 3. Gotta match your parentheses. So I'm going to start off, and you take your g of x function and you plug it into c, right? So if I take my c, trying to figure out exactly how to write this. So if I'm going to do c of g of x, that means I do absolute values, because that's my c function, and I'm plugging g into that. X minus 1. Cool. And then on the very out, and then I'm going to take all that stuff and plug it into t. So then I'm going to take all of this stuff. So I'm basically doing t of this now. So I'm going to take all of this stuff and plug it into t. 3 square root, because it's my t function, absolute value 8 over x minus 1. Ooh, looks like this piece right here. Oh, nice job. And again, they'll kind of explain it the same way. So plug g of x into c of x, and you get this. Then take that and plug it into t of x, and you'll get this. Oh, those ones are tricky. Let's try another one. It's kind of like a puzzle you're just figuring out, though, right? All right, so this one I'm doing q of c of s of x. 1, 2, 3. All right, starting off with our first piece, I'm going to take my s of x function, and I'm going to plug it into c of x. So my c of x is my outside piece, so I'll have stuff plus 4, and then I'm plugging s of x into there, so I plug that into there, square root. Wonderful. And then now I'm finding q of that stuff. Oops. Q of that stuff, right? Because that's what all the inner piece was simplifying to. Okay, so now when I find this whole thing, I'm going to take my q function, which is 7 over stuff, and then the stuff that I'm plugging in is absolute value, 5x, absolute value, plus 4. And it looks like that's B. All right, one more. All right, for this one, I'm finding C of S of Q of 3. Lovely. We'll start off with s of q of x. So I'm going to take my q of x and I'm plugging it into s. So my s is the outside piece, and then I'm taking q of x and plugging it in. So 4 over x. Lovely. And then now I'm finding c of that, which means that I'm going to, my c function is the stuff to the fourth, so I'm going to do stuff to the fourth minus 5, and then the stuff I'm plugging in is the square root of 4 over x. So I think it's this top one. No, careful, it's the square roots on the whole thing, not just the bottom piece, so it's the third one. Woohoo! All right, so those ones might be the trickiest ones, but there's some help with them.